everyone. Today I'm going to be talking about phocids, which can also be called true seals. So let's get into it. All right, so this is the list of things we're going to go over today. I'm going to start with an overview of the whole family, and then we're going to get into the weeds and start talking about the biogeography and distribution of the Phocidae family. And finally, we're going to finish off with the future anthropogenic problems that they're going to be facing. So the family Phocidae is found throughout all the world's major oceans except for the Indian Ocean, and they're considered the world's most widely dispersed semi-aquatic marine mammal. They can be called earless, crawling, or true seals, and this is to distinguish them from others under the order Pinnipedia, which are all seals, and sea lions, walruses, everything like that. So there are 19 living species of Phocidae and one that has been semi-recently considered extinct. And most of them reside in colder waters, but there's a few exceptions to that. First, I'm going to start by distinguishing Phocidae from Otaridae. So you can see that it is true seals and fur seals. So firstly, as you can see here, their rear flippers are for swimming and can't face forward as the fur seals can, and that means that they're not great at moving around on land. They also have no external ears. They still have ears. They're just, they don't have any structures on the outside of their ear that could be seen. They also have shorter necks, and although it's not in these pictures, they also have internal testes, unlike fur seals. All right, so this is the phylogenetic tree for the order Carnivora, which includes all the seals, walruses. It also includes otters and polar bears. So the crosses to the right mean that those are the individuals that have gone extinct, and the bar at the top refers us to the time frame. So as you can see, it's they have a pretty considerable evolutionary line. I'm going to show you a couple key points here. So that right there is where they diverge from bears and otters. Right here points out the diversion between sea lions, walruses, and the other pinnipeds. And right there is the divergence points between the phocines and the monachines, which we are going to focus on the monachines today, but I'll get into that in a second. And you can also see here where the monachine lineages break off into separate branches, but we'll touch on more of that. So there's two subfamilies within the family that we're going to be looking at. There's the Monachinae, which is the southern phocids, the southern and northern elephant seals, and the monk seals, and the Phocidae, which consists of just the northern seals. Because it's such a broad group, today we're going to be focused in on the monachines. So this is the extinct species that I mentioned earlier. It's within the subfamily of the monachines, and it was called the West Indian monk seal, also known as the Caribbean monk seal. Human impacts such as hunting, habitat destruction, and global warming all contributed to the seal's extinction, and it hasn't been seen since 1952. That's over 69 years. So as of now, it's presumed to be extinct. Although it is the only extinct species in recent years, many other true seal species are considered endangered. All right, I'm going to get rid of this title here for historical distribution because it is going to get a little convoluted, but let's get into it. The extinct phocid sister taxa, Desmotophocidae, was first found in the North Pacific 20 to 23 million years ago. Basal phocids and monachines first appeared in the fossil record in the western North Atlantic 15 to 17 million years ago. They're thought to have traveled from the North Pacific to the North Atlantic in two possible ways. So the first way is right there, southward through the Central American Seaway. And the Central American Seaway was open during the early Miocene. There was an abundance of marine corridors through there, and a southern route would have allowed them to maintain temperate water, which was they were fond of at that time. And desmotophocid fossils can be found as far south as Southern California. So those are kind of the reasons why they believe it go that way. Or they also thought it could have gone north through the Arctic, though there's not as much evidence to support that theory. Once in the Atlantic, basal phocid seals diversified. A group dispersed north to the cooler climate of the Arctic and subarctic regions, which is the Phocinae. And the other group maintained their warm water affinities on diversified eastern and western parts of the North Atlantic, which are our monachines. And basal monachine fossils can be found in the eastern and western North Atlantic and in the Parthenia region, which is now the Black, Caspian, and Aral Sea of Asia. This leads us to believe the transatlantic dispersal east and west happened in the mid-Miocene. Based on the map you just saw, it would make sense you would think they wouldn't be able to travel through there, but this is actually what the oceans looked like at that time. You can see there's a really big area right here, a very easy passage corridor through there. And it allowed for easy passage from the North Atlantic to the Tethys Sea region, which is what that area was called. Though it has been closed off, obviously now it doesn't look like that, but that's how they got there. It wasn't as difficult as it would have been now. I'm just gonna show you that on the map there so you can keep track. There's the Monoceros and the other two there moved. And basal labondontines then disperse from the Atlantic to the Pacific through the Central American Seaway, as you can see there in the orange, and then migrated southward along the Pacific coast of South America. Labondontini and the Marungas diverged between 9.1 to 10.8 billion years ago. And I also want to bring up the Califoca, which is the ancestor taxa of the Marunga. They're present only in the early Pleistocene and was located in the western North Atlantic and Europe. The two diverged from 2.7 to 3.4 million years ago by either dispersal or vicariance. If dispersal, then Califoca and Marunga would have occurred from east to west through the Central American Seaway, then do a southward migration from the equatorial Pacific to the eastern and south Pacific. Fossil monoecious individuals were found in southern Europe and nowhere else where fossil remains can be found. This led to the theory that this clade evolved only in the Tethys Sea. These lineages are what we know as the monk seals today. The Mediterranean and the Hawaiian monk seals split between 10 to 11.6 million years ago. The monk seals' dispersal into the Pacific is most likely took place in two dispersal events. So the first one, as you can see there, would be from the Mediterranean to the Caribbean through the North Equatorial Current. And the second one is the Caribbean to the Hawaiian Islands through the Central American Seaway around 3.5 million years ago, or possibly. So to simplify our map, because I know there's a lot of lines going on, I'll outline it like this. What we now consider the monk seals are found here. The one living lineage of the Calicofoca, aka the elephant seals, are located in the North Pacific and one in the South Pacific. There's only two. And finally, we have our southern seals, Labondontini, and is the most southward group, and Marunga, which is located slightly more north, as you can see. And here's another look into the ecological biogeography of the three clades in today's context. You can see how Monoceros is the most north and very connected to land masses, and Marunga is much more south, and the Labondontini is the most south, but intersects with the range that Marungus also lives in. These bands are very clearly linear, as you can tell, because seal distribution is very dependent on water temperature. Once they diversified, these seals specialized to certain temperature and the prey that reside within that range. So accessibility to land and ice forms also becomes specialized between the groups. So you may be wondering why they moved so far south if they were originally located in the Atlantic. And that's because there was new niches to fill in higher latitudes. There was high oceanic primary productivity because of glaciation in the southern hemisphere. And once adjusted to those regions, they diversified and grew out of their ability to live in any other type of waters, as you have seen. And this greatly affected their. So elephant and monk seals all adjusted to breeding on land, while southern monachines breed on either fast or pack ice. Basically, what that means is fast ice is on land. Fast ice is another name for it, which refers to the large solid ice sheets that are attached to land, or pack ice, which is the smaller free-floating pieces of ice. So they really specialized to that and can't breed in other ways. And so the anthropogenic impact is actually really, really important for them. As mentioned, some pinniped species rely on sea ice to raise their pups, and without it, they're deeply in trouble. That's one way to connect to global warming because, as we all know, it is greatly impacting the disappearance of sea ice. And another one, which is less of a concern now, but is always part of the life of being a seal, is being hunted. Hunters targeted seals for their pelts, and it has led to the extinction of several species of. And the final one I'm going to talk about is microplastics and bioaccumulation. Bioaccumulation is the gradual accumulation of substances within an organism. So I'm going to show you a little graph here that explains it really well. So organisms at the bottom of the food chain, like shrimp and small fish, eat microplastics. And at low concentrations, they're not dangerous to the individual. The problem is when a predator, like seals, eat lots of prey, that it accumulates in their stomach and it can actually cause harm or even death to the individuals. And a study of the feces of seals in the Eastern Pacific Range found that microplastics are in over half of seal specimens with a considerable amount that would have definitely caused damage to them. Yeah, I'm just going to show you here my references, and that's pretty much it. Thank you for listening to my presentation. I hope you learned something about seals that you hadn't already known.